In this video, we're going to continue to extend our factoring know-how by looking at how to factor difference of squares. But before we can really talk about how to factor difference of squares, we need to talk about what difference of squares are. First of all, in math, the word difference means subtraction. And then when we're talking about squares, we're talking about perfect squares, such as things like 9. 9 is a perfect square because it is 3 times 3, but then x squared is also a perfect square because it's x times x. So anything that can be square rooted down to a nice number, a whole number, we would call that a perfect square. So the long way to say difference of squares would be to say the subtraction of two perfect squares. So what one of those might look like is something like x squared minus 9, because x squared is a perfect square, 9 is a perfect square, and they're being subtracted. We could also say 9 minus x squared, and it's important to note that these are not the same thing. So these are both difference of squares, but if I rewrote this one in descending order, it would become negative x squared plus 9, which shows in one way that it doesn't equal back to this guy. They're both difference of squares, but they are not equal. Also with this bottom guy, you would not want to write this in descending order. When we're factoring difference of squares, you actually want it expressed with the difference in the middle. Even though it looks awkward, you wouldn't want to rearrange it. So another example of difference of squares would be something like y squared minus 25. And we could also do something like x to the 8th minus 64. 64 is a perfect square. X to the 8th can be seen as a perfect square because it's x to the 4th squared. If you unsimplify the exponent in such a way that you have a square as your dominant exponent, then that can be expressed as a perfect square. And in general, anything that is an even exponent can be reconfigured in this way. Now let's look at a few things that are not perfect squares. So first of all, if it's addition, such as x squared plus 9, that is not a difference of squares. They're both perfect squares, but that's a sum of squares, and that's not what we're talking about here. We're talking, it has to be a difference of squares for what we're going to be doing to work. Let's say you have 2x squared minus 16. So here x squared is a perfect square, 16 is a perfect square, but 2 is not a perfect square. Since 2 is not a perfect square, the whole term is not a perfect square, and so this is not a difference of squares. Same thing if you had something like y squared minus 8. 8 is divisible by 2, and so sometimes students will be tempted into thinking of it as a perfect square, but it can't be square rooted to a whole number. It can only be divided by 2 to get a whole number. So this is not a perfect square. Hopefully that gives you a sense of what is and is not a difference of squares. Now that we have a sense of what we're talking about, now I want to talk about where these come from. Because remembering, factoring is undoing multiplication. So in order to think about undoing a difference of squares, it would be nice to know what was multiplied to create these things. In other words, factoring is undoing multiplication. So now we'll look at what multiplication creates difference of squares. So let's multiply x minus 2 times x plus 2. We've talked about these before. These two binomials are called conjugates of each other. First we'll multiply the x times the x. That's going to give us an x squared. And then we'll multiply the x times the 2, and that's going to give us a 2x. Then we'll switch and multiply the negative 2 times the x. That's going to give us a minus 2x. And we'll take that negative 2 times a positive 2. And that's going to give us a minus 4. Hopefully the multiplying of polynomials is getting more comfortable for you as we do more and more of those. Now that we have those multiplied out, we see we have these two like terms in the middle that can combine, but they're opposite. We have 2x minus 2x, so that's going to add to 0 or cancel out, so we're left with x squared minus 4, which is a difference of squares. And this is going to happen every time we multiply conjugates, because we will always get this behavior in the middle where the terms cancel out, because when we multiply these two guys, we're going to get the opposite of when I multiply my outside terms. And so we're always going to get those middle two terms to cancel out. Also, we can see that when we multiply the first two terms, those are always going to match because of what conjugates are. And so that's going to always end up in being a perfect square, which gives us the perfect square we need to create a difference of squares. Similarly, when we multiply the last two numbers, that's going to give us a perfect square. And since one of those with a conjugate will always be negative, it'll give us a negative perfect square, which is what we need to construct this difference of squares. And so now we can see that difference of squares comes from multiplying two conjugates together. Now that we see that, we can use that pattern to factor them back out. Let's get into some factoring examples to see how this might work. Alright, for our first example, let's say we have the difference of squares x squared minus 25. Now, this factoring doesn't take a lot of work. We know from what we just saw that this is going to factor as two conjugates. What goes in the first slot is going to be the square root of our first term. So the square root of x squared is just an x. So we put an x in each slot. Now we look at our second term in our difference of squares and we square root that. In this case, that's a 5. So we're going to put a 5 in our end slots. And to create the minus, we know we need conjugates. So one of them needs to be positive and one of them needs to be negative. It does not matter what order you put the positive and negative. So it would also be correct to say that this difference of squares factors as x minus 5, x plus 5. And that's it. We have it factored. Let's do another one that's a little bit more complicated. Alright, let's say we have the difference of squares 4x squared minus 49. So again, we know these are going to be conjugates, so I like to set my parentheses up first. And then first we want to look at the square root of the entire first term. This time we have a coefficient in front of the x squared, but we just square root that as well. The square root of 4 is 2. The square root of x squared is x. So what goes in our first slots would be a 2x and another 2x. And then we look at the square root of 49, which is 7. So I put a 7 for my second slots, and then they need to be conjugates, so one is a plus and one is a minus. And that's it. It's all done. I will tell you, for factoring difference of squares, it'll be helpful if you know your perfect squares, such as I look at a 49 and I think 7 squared. So if you know the first several of those, say through 12 squared, which is 144, that might help you identify these quickly and break them apart quickly. Let's do another example. Alright, let's say we have 9x to the 6th minus 16. I'm going to start by setting up my parentheses. And then I want to square root my first term here. The square root of 9 is 3. The square root of x to the 6th is going to be an x to the 3rd. Because if I take x to the 3rd and square it, I get the x to the 6th. So I'll put that in both of my first slots. And then I square root the 16, that gives me 4 for both of my second slots, and then one's a plus and one's a minus. Let's look at one more example. Alright, let's say we have 25 minus 9y squared. Now this one looks funny because the variable term is second, but if we switched it around, it would no longer be difference of squares. So we don't want to, even though it isn't a complete error, it won't get us to where we're going. So you don't want to do that. You don't want to put it in descending order. You want to leave it so that it's a difference of squares, because once we switch it around, now it's a sum. So to factor this, I just set up my parentheses, and I take a square root of the first term. That's 5, so I'm going to put a 5 in both of my first slots. Now I'm going to square root the second term. The square root of 9 is 3, and the square root of y squared is y. So I put 3y in my second slots. And then we want them to be conjugates, so one's a plus and one's a minus. And that's all we have to it. So hopefully you're seeing how the pattern works. I would say that if you're not confident in just breaking them apart like this, always remember that you can re-multiply to check yourself. And so I should be able to take these two conjugates and re-multiply them and get back to where I started. If I don't get back to where I started, I've made a mistake somewhere. Of course, the mistake may be in the multiplying, but they should be able to go back and forth on each other. Alright, go ahead and give some of these a try and see how you end up.